Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's have the proper notation for the antiderivative of the function. Antidifferentiation is the process of finding the set of all antiderivatives of a certain function. We understand that for a certain function f of x here, we will have here other function f of x if it satisfies the idea that the derivative of that given function with respect to x would be equal to our original given function here. This is per the definition of the antiderivative of a certain function. But of course, this time, let's try to come up with the correct notation and some ideas we need to follow when we talk about antiderivative of a certain function here. Now, the notation that we use is this symbol here, we call the integral symbol. Okay? That would mean if this is satisfied where our f of x, the capital letter 1, is the antiderivative of our given function here, f of x, we can write it in this manner that the integral of your f of x dx will be equivalent to its antiderivative. Okay? This means that the connection between the two functions is that one is the antiderivative of the other, and that is the result here. Okay? So this is oftentimes used to denote indefinite integral and will be used later on to denote as well definite integral. Yes, the idea of integration or integral is actually related to the antiderivative or the anti-differentiation. But of course, we need to understand here that for this specific notation, there are a lot of possibilities for a certain function to happen. That is why for your solutions later on, we always write here any plus c. This would be any arbitrary constant that we actually just write here to satisfy the idea that antidifferentiation is the process of finding the set of all, again, set of all antiderivatives of a given function. Now, we used this example before. Let's say our f of x is actually 2x, and we have determined that its antiderivative is actually x squared. But it's not just x squared alone. That is why we are going to introduce here our plus c, because no matter what that value of c is, it would satisfy the idea that this derivative of our capital letter f of x with respect to x would be actually equal to 2x here. Let's just say, what if our function here, let's say x squared plus 1, its derivative with respect to x is actually 2x plus 0, or just simply 2x. This also follows if you have here another function, let's say x squared minus 9. Its derivative with respect to x would still be 2x plus 0. So we can see here that even if we have plus 1 here, we have minus 9, or any constant that you can think of. You can even use pi and other constants that you can think of. We will always have the value of 2x for our derivative, which corresponds to this given function here. That is why we really need to introduce the plus c in our solution once we are looking for the set of all antiderivatives, so that we will not just be ending with one possible value or possible function. It would actually encapsulate all types of functions starting with x squared plus any constant here. Again, any constant, maybe fraction, irrational numbers, negative numbers, as long as they are actually considered to be constant. Now, before we end this video, because the next one, we will be talking now with some rules to follow, there is an important idea that we need to understand or realize here before moving forward. Let's talk about this idea here. This notation on the right side. This is read as the integral of our f of x with respect to your x. And yes, we know that it is equal to f of x plus c. The point here is that this is true once our notation here is with respect to x as the variable inside the given functions here. Because if you will have another notation here, let's say f of x, but you have dy, you cannot say that this is equal to your f of x plus c. That is because your notation here is with respect to y, and your function of x here, we don't know that form of the f of x. It might be f of x alone or just other containing other terms as well. This is to be integrated with respect to y, so we cannot claim this equivalence as well. The point here is that this is only true, the notation for antidifferentiation or the process of finding the set of all antiderivatives of a given function with plus c is only true if we have here the same variable where it is with respect to. And of course, it would satisfy all the necessary concerns here. In the next few videos, we're going to talk about the rules on antidifferentiation and some examples, because we have different rules for different types of functions, f of x here. Thank you very much for watching. So what are you waiting for? Subscribe now.